Hi there, everyone. This is Miss Chelsea, and we are going to go over our next exam, Module 3, Chapter 10. Let me get it pulled up here. It's going to go over the length, area, and volume. So for the first question, we are asked how many mouthfuls are in 1 gill. Pretty easy to solve, but for me it's a little easier if we draw it out so that way we can visually see how much each measurement is. So we're going to start off with 1 gill, and within a gill we can fit 2 jacks. And within each of those jacks we can fit 2 jiggers. And within a jigger we can fit 2 mouthfuls. So you can just say 2 times 4 would equal 8, or we could just go ahead and continue to fill up the jiggers with those mouthfuls here in our visual representation, and we can add those and we see that we have 4 on top, 4 on bottom, or we have 8 mouthfuls total in 1 gill. Next, we're going to look at how many mouthfuls are in 1 cup. So first we're going to start with 1 cup. And within 1 cup we can fit 2 gills. And remember, in each gill we can fit 4 jiggers. And within each jigger we can fit 4 mouthfuls. So if we have all 4 mouthfuls in each one, we can multiply the 4 times the 4, or we can count them out. We have 4 on top by the 4 here. So we have 16 mouthfuls in 1 cup. And in the next question, we are asked how many, I forgot to ask the question there. So for 1 pint, we have 2 cups. We're going to find out how many mouthfuls can be filled with 1 pint. So again, in that 1 pint, we have 2 cups. And in each of those cups, we can fit 2 gills. And in 1 gill, we can fit 8 mouthfuls from that previous question that we worked on. So if we just go ahead and plug in all of those mouthfuls into each one of those gills, we'll get 8 in each one. And then we can do 8 times 4, which is 32. So we know that we will have 32 mouthfuls in 1 pint. And next, we're asked to take an empty pail, and we're going to fill it with each of the measurements that were given, which was a gallon, a bottle, a quart, and so on. So we're going to start off with our empty pail, and we're going to fill it with a gallon. We know that 2 gallons can fill up the pail, but we're not asked to put 2 in. We're only asked to put 1. So it takes up half of our pail. Next, we're going to dump in 1 bottle into our pail, and then 1 pint, 1 cup, and in that 1 cup, we can get 1 more gill in there, 1 jack, 1 jigger, and 1 mouthful. So that's all we're asked to put in there. But we still have a little empty spot here in our pail to fill up a little bit more. What do you think is a big enough measurement that will fill the pail just right without overflowing it? We could add 1 more mouthful, because if you look at this mouthful here, the little green square or rectangle figure, we could fit 1 more of those. So that will fill our pail completely. So to get the pail full where it will not overflow, we can add 1 gallon, 1 bottle, 1 pint, 1 cup, 1 gill, 1 jack, 1 jigger, and 2 mouthfuls. And for our next question, we are given this figure here with some measurements, and we are asked to find the area. So to find the area of this triangle, our formula we're going to use is A equals 1/2 base times height. So we know our base is going to be 82.3. So we're going to plug it in for B, and our height is the 41 meters. So we're also going to plug that in for our H. And then we would just do the math, which would give us 1,687.15 meters squared. Because we're using 2 different meter units, we're going to square that. Next, we're asked to find the perimeter. And to find the perimeter, all you have to do is add the areas of the sides together. So we have 48 meters, 82 meters, and 69 meters. Once we add those together, we get 199.3 meters. So the perimeter of this figure given is 199.3 meters. So here's our area and our perimeter. Super, super easy. And next, we're given another figure, and we're also asked to find the area. And again, to find the area, we use the formula A equals 1/2 times base times the height. So for this one, our base is 88.8. And one way to kind of know that is it's going to be the one directly above the hypotenuse. The hypotenuse is this slanted line that you see here that measures 96.2 inches. So we know that our base is 88.8 inches, and then our height is going to be this, this length here, the 37 inches. So we plug that in, and that will give us 1,642.8 inches squared. Again, we're going to make it squared because we're using 2 units of measurement of the inches, so it's going to be a square. Now we're also asked to find the perimeter again, so we're going to add all of the sides together, 37 plus 96.2 plus 88.8. Sorry about that. That's going to give us 222 inches. So there's our area and our perimeter again. And for the next problem, we're given another figure here, and we're asked to do the same thing. It just looks a little trickier because of this dotted line here and this up and down arrow. So what we're going to do, well, first we're going to find the area and use that same formula as before, 1/2 times base times height. And our base is obviously going to be this 6.2 because directly above it is that hypotenuse again. So we're going to multiply the 6.2 times the height. Now the only thing that we know up and down wise for measurements is this 2.6, so we're going to plug that in for our height. And then once we calculate that, we're going to get 8.06 centimeters squared. And next we're asked to find that perimeter again, which is every angle around the figure. So we're going to do the 6.2, 3.1, and 8.5. And we're going to add those together to get 17.8 centimeters. So again, our area is 8.06 centimeters squared, and our perimeter is 17.8 centimeters. And on this next question here, we are given a circle inside of a square inside of a larger circle. And what we need to do is we're wanting to find the amount of space between the two circles. So basically, we're just wanting to know the amount of space that that square is taking up. So the measurements for the square is going to be 10 on each side. So first, what we're going to do is we're going to find the radius. We're going to find the radius of the square. So the square is 10 on each side, so that means half of that 10 is going to be the radius. So our radius will be 5. Now we're going to find the area of the smaller circle. And here I have shown you the formula to find the area of a circle. It's going to be pi times the radius squared. So we're going to multiply that radius that we got times itself. We're going to square it, and then we're going to multiply it by the pi. So once we plug that information in, pi times 5 squared, we are going to get 79 pi units squared. Next, we're asked to find the radius of the larger circle. Again, we're going to plug that into that same formula above. We are going to do the Pythagorean theorem. So it's going to be a squared plus b squared equals c squared. So we're going to do a squared, which this is again all based off of that square that we have. So we're going to use the radius squared plus the radius squared equals our c squared. We're going to find our radius squared here. So that's going to be 50 equals radius squared, or r squared. So in order to get rid of that square, we have to do the square root of that. So we're going to find 50 pi units squared. And then lastly, how we're going to find what that space is with that square, we're going to subtract the area that we got from the larger circle to the smaller circle. And that is going to give us 79 pi minus 50 pi. And our answer for the area in between the circles is 91 pi units squared. Next, we're given this shape here, this figure, and it has a cone and then a sphere, and all of that is inside of a cylinder. We're asked to explain how it could be a ratio of 1 to 2 to 3. So first, what we're going to do, we're going to find the volume of the cone. And to do that, we're going to use this formula. So we're going to use 1/3 times pi r squared times 2r, and that's going to equal 2/3 pi r cubed. Because again, we have those two units right here, measurement, the r squared plus that other r, so it's going to give us a cube. And then we're going to find the volume of a sphere. And for that, we're going to use 4/3 pi radius cubed. And last, we'll do the volume of a cylinder, which we will use this formula. We have the pi r squared times 2r equals 2 pi r cubed equals 6 over 3 pi r cubed equals 2 pi r cubed. The mouthful. So to know that it's a 1 to 2 to 3 ratio, if we were to fill up the cone one full time and then dump that into the sphere, it wouldn't completely fill the sphere up. It would only do it about halfway. So we would have to do it 2 times. So one cone would go into the sphere 2 times. That's the 1 to the 2. Now the 2 to the 3 is if we were to take that cone and fill it up once, dump it into the cylinder, it would only fill it up 1/3 of the way. So if we dumped it in there 2 more times, that would be 3 cones would go into the cylinder. So that gives us the 1 to the 2 to the 3 ratio. And next we are given this figure here, and we are asked to name the figure first, and this is a right trapezoidal prism. Next, we need to find the surface area. And to do that, the formula we use is 2 times b plus ph, which is the base plus the perimeter and the height. So first, we're going to start off with finding the base. What is the base here? The base in this figure, we're going to use the formula b equals 1/2 times a plus b times the height. So we're going to have our a is going to be this 26 over here on the far left, the 26 centimeters. And then the b is going to be the 17 centimeters on the other side, times our 12, which is our base here, the b is 12 centimeters. So if we do the math, we're going to get 258 centimeters squared. Well, next, we're going to find the perimeter of all the sides together. So we're going to do 16 plus 12 plus 17 plus 15 equals 60 centimeters. And next, we're going to plug all that information that we just found for the base and the perimeter, and we're going to plug it into our first formula that we had, the 2b plus ph. So we're going to have 2 times the b, which is the 258 centimeters squared that we got, plus the perimeter of 60, then the height of 4, because we have the height of this line back here, 4 centimeters. Plug that into our calculator, and we will get the surface area is 756 centimeters squared. And next, we are given this figure, and we're asked to name it as well, and it's going to be a right triangular prism. So first, what we're going to do, same as before, we're going to find the base of a triangle. We're going to use the formula of b equals 1/2 times base times the height. So we're going to have 1/2 times the base, which is 8, and the height is 15. Because if 8 is the base, that means we're basically flipping the shape on the side, and then that 15 is what's going up and down. So that's the height. So if we plug that information into that formula, we get 60, and then, 60 meters squared. Forgot to mention the meters. Next, we're going to find the perimeter, which is, again, the sides. We're going to add each side together, and we're going to get 7 plus 17 plus 15, and that will give us 39 meters squared. And lastly, we're going to plug all of that information again into the surface area formula, which is 2b plus ph. So we're going to have 2 times the base of 60 plus the perimeter of 39 and the height of 15. And that will give us our final answer of surface area equals 705 meters squared, or 705 meters squared. And next, we're going to look at this shape here. It looks like it's 2 shapes in one, so it's a little trickier to work with. So first, we're going to look at the sphere. So for the sphere, we're going to look at the surface area. The formula will be 4 pi r squared. And then the surface area of a cylinder is 2 pi r h, which is 2, and then pi times the radius times the height. So the formula for this entire figure as a whole would be 2 pi r times height plus 4 pi times r squared, or just 4 pi r squared, however you'd like to say it. So first, we're going to plug our information that we are given here, the 8 foot and the 21 foot, and we're going to plug that in. So since the radius is only half of that 8, we're going to use the 4. We're going to use 4 for the radius. So we're going to have 2 pi times 4 feet times 21, which is the height, plus 4 pi times the radius again of 4. And that's going to give us 578 feet squared. Next, we're going to find the volume of this figure. And to do that, we're going to use the formula 4 over 3 pi r cubed plus pi r squared times the height. So if we just plug that information in that we already know, the 4 is the radius and then the height is 21, we can plug all that in and we'll know that the volume is 604 feet cubed. So overall, our answer for the surface area is 578 feet squared and our volume is 604 feet cubed. And next we're going to look at this figure. We have the a cone and a cylinder. In order to find the surface area, we have to do it for both of those. So we'll add the surface area of a cone to the surface area of a cylinder to find the surface area of the entire figure. So our formula is going to be S equals pi r squared plus pi r s plus pi r h. So we're going to talk about those r's and s's and h's again. The r is going to be the radius. The s is the slant height. We have a slant here on our cone of 6 meters. And then our height, which is the 10 meters. And we're already given the radius. We don't have to break it in half because that is half of the diameter of the circle or the bottom of the cone. So first we're going to look at the formula we were given and we're going to plug that information that we know into that. So we're going to have S equals pi times 2 meters squared plus pi times 2 meters times 6 meters plus 2 pi times 2 meters times 10 meters. Again, it's a mouthful, but once you know what those letters stand for, the R, the S, the H, it's super easy. You can just plug it in into your calculator and it'll give you the answer there. Just knowing what those letters mean is key. So once we plug that in, we get 176 meters squared. And then next, we're going to find the volume. So we're going to use this formula here. Volume equals pi r squared h times height 1 plus 1/3 base times height 2. We're given h1, the height 1, which is 10 meters, but we're not given height 2. So what we need to do is find that. And in order to do that, we are going to take the square root of 6 squared minus 2 squared. So once you square those, and then you take the square root of it, you get 5.66. So the height 2 is going to be 5.66 meters. And then lastly, we're going to plug it into our original formula here listed in step 2. The V equals pi r squared height 1 plus 1/3 base times height 2. And once we plug that information in, we see that our volume is 149 meters cubed for this figure. All right, and that is it for Module 3, Chapter 10. If you have any questions, just let me know. Thank you so much for watching.